In the Placerville area, this is from Division of Mines Geology, Bullet 135. There's a 1946 map of the tertiary gravels. This is the main Placerville located in the center, right in here. This is the main Maloney's Fault Zone. Goes right down through the center of Placerville, goes right down through Plymouth. North of Placerville, the Maloney's Fault Zone goes up here, and then you cross the river at Chili Bar, and the fault zone splits, and it goes on both sides of Georgetown. This is one side here, and this is the other side over here. The side over in this area here runs through Overnight Trails, which would be the eastern entrance of Overnight Trails. On the right-hand side over here, this runs through, this would be Georgetown, and you take the Wentworth Springs Road out of Georgetown, like you're going to Lake Edson. When you get on about 4 miles, there's a big bend in the road where there's a massive serpentine outcrop and a lot of digger pines. That marks the fault zone in that particular area there. But then this is the Rage area. This is the tertiary gravel stream that came out from down the South Fork down through this Pacific House. This is the Camino, and then it comes down through Placerville. There was a little loop that ran north of Placerville, runs through Placerville, out through Gold Hill Road, and out through this area here. Here's Lotus, and then this is through Pilot Hill, and then it comes down through Loomis and Rockland. And in fact, in Loomis and Rockland area, I've gone over there as a consultant several times, and the town of Loomis was built over the top of the underground workings of the tertiary gravel mines in that area. And they're having the same subsidence problems as we do in the Placerville area.
Oh, George, on this, I'm marking the map real quick with my little laser beam here, but can you see that picture, the mark I put there? No, you can't see it to the screen. This word, is that tertiary, and then the gravel's right there? There's right there where it's just, is that the word tertiary, or is that some kind of scribble? That's what it means, right?
Lotus, I can't see that it's too fine a print.
Yeah, it looks like tertiary, and then gravels, and then river right there. Where behind there, I was looking at this map really closely because it's
Pilot Hill, if you go through Pilot Hill, and you go up toward the gentle slope out of the town side, up toward the top of the hill, that whole town is underlain by massive tunnels and underground chambers that are 20 feet thick from the surface of the ground, 20 feet down, and then these massive rooms where they mine the gravels out underneath.
yeah, that's how wide is that now? Because that's where my mine site right there is.
That stream is half a mile wide.
Right, it's really narrow, right? Yeah.
But then in Plymouth or in Rockland, Loomis, it goes across the canyon. But this is the major stream in our area. The one that runs north of Placerville goes up through Gold Block Park. And on where the stamp mill is there, the sugar pine mill, right around that side you'll see round white quartz cobbles from that particular stream. And the white quartz cobbles can be even traced down on Missouri Flat Road, on the Coon Hollow, and actually you'll find white quartz cobbles out behind 4 Reds, where the parking lot is out there. So when we mapped the geology of that area, we always planned, so we started in Placerville, and we ended up with 4 Reds in front of you at about 3 o'clock. So we could
Way to go!
get out of the outside and go there and
What was your famous statement from that?
enjoy that golden Cadillac.
You have a famous statement from there somewhere, I read somewhere, it says something about,
Oh, yeah. As a word of encouragement in a geology class, to give encouragement to students, I have quotes from different poets and stuff. And one of the quotes is that Edison didn't bitch about darkness. Poor Reds, Professor
that was
Wheeldon.
nice, huh?
But this shows them the main hard rock mines and the tertiary gravel mines in the immediate Placerville area. If you take a look at this, these gravel deposits were buried by volcanic flows, and then these things, now as the Sierras were slowly uplifted, streams cut down through, and they cut down through. Here's a Pleasant River, here's a Pleasant River, and left isolated these volcanic flows on the top that were burying these old stream beds that contain the gold. And so this is a typical cross section. Here's the serpentine, which would be associated with the hard rock bands. Here is anesthetic mud flows and lavas and channels and stuff. So this is the relationship. And we'll spend a couple nights on the tertiary gravels of the Forest Hill Divide. One of the really interesting mines is the Wesky Channel that came south of Forest Hill. And this was a cemented gravel, and they tunneled in there looking for the gold. They ran across a 4-foot diameter, 100-foot tall cedar tree. It was standing up, surrounded by gravel, surrounded by volcanic flows in that area. Most of the channels, buried vegetation and trees and stuff. And you see it. This is, I worked on about a dozen mines up there over the years, and this is one of the staff geologists in the hazard mine. And you can see the round, smooth columns of the stream, and he's picking with his hammer in areas like this. These are the smaller pieces, and gold is associated in these areas here. And this is 600 feet vertical below the lava cap, below the surface. So there's one of the old streams. To give you an idea of the size of the stream, 10 miles east of Forest Hill is the Mountain Gate Quarry, and this is the bottom of the Mountain Gate Quarry that runs from here, this view right here, and I'll give you another view. This is the contact zone, and this is all white quartz gravels. That stream in that area was 800 feet wide and 200 feet deep of white quartz gravels. They tunneled in the edge of that particular line and tunneled 8,000 feet underneath that cap, following the gold. And it ended up in the other direction, being intersected by the hidden treasure mine, which came up 7,000 feet. So huge, huge mining deposit in gold in that area. Now, the volcanic flows that filled up these old streams. In California, what potential do we have of volcanoes erupting in Placerville today? Region. There are areas in California in which we can have volcanic eruptions at any time. This is the 1915 eruption of Mount Lassen, taken from Anderson, 50 miles away. Lassen's an active volcano. Shasta's an active volcano. Mount Canocti in the Napa Valley is an active volcano. The Calistoga hot springs are there because there's a magma chamber underneath there that heats the water up that bubbles underneath the mud and stuff that you bathe in when you get a mud bath in Calistoga. Don't. How many other people have used that mud for whatever purpose before you get into it? Just let that run through your mind. Here is Shasta, and they mapped the potential for flows. Is that Wheeldon and Mount Shasta will be covered. It will cover with I-5. You'll have trouble getting to the Shakespeare Festival in Ashland. This is Mount St. Helens, one of the largest, most intensively studied, but this is part of the Cascade Range volcanoes. Here's a historic record of Cascade eruptions. These are the Cascade volcanoes, and these are the number of eruptions that have occurred in the last couple thousand years. These are active volcanoes. The major ones in this area here that I show to emphasize that these things can get big. This would be St. Helens, which would be right here. This is the smallest of them, 1980 eruption. It went across Idaho into Montana. This is then the boundary right in here, the dark boundary in here, is Lake Mazama, which is Crater Lake, right on the Oregon-California border. You have blue ash in that area there. The hatched area with these little speckled, little inverted T's going around in here is what we call the Rockhunt volcanic eruption, which is the one that created Mount Lassen. This is the volcano that existed prior to Mount Lassen coming in. When it blew up, it put volcanic ash and covered the Bay Area of San Francisco. It covered Northern California, went over to Idaho, Utah, and that area there. And the biggest one is this gray one down in here, and this is the Bishop Tuff. And this occurred 760,000 years ago. When we take our trips to Mona Lake, we stand on the edge of that and realize that the Mammoth ski area is then the western caldera, edge of the caldera of this big gigantic eruption. When Bishop Tuff blew up, it put volcanic ash into the state of Nebraska. It covered Southern California. It went clear up and through completely blanketed. And that's only 700,000 years ago. These are the streams down through our area, the American River, then up in the Forest Hill Divide, those areas. But we have these also streams coming out of central Nevada, and these streams cut down in the ancestral Sierras. They were lots of gold in those streams. Here is then a kind of cross-section of San Francisco Bay Area, the Great Valley. This is the Sierra Nevada, and this is the highlands area of Nevada that generated these super volcanoes that buried these ancestral streams that ran through what we now know as the Sierras, through the Central Valley, and come out into the coast. We have evidence of this volcanic flows that are pretty recent. The Lovejoy basalts, about 16 million years old, came from the Honey Lake area, up here by Quincy area. It flowed down through into the Sacramento Valley, and some of it went down as far as Vallejo. And this is the 16 million years ago. It erupted from fissure beds near Honey Lake before Honey Lake Depression flowed in that area. This is the Eureka Valley Cup, and this is the cup that is, to me, is just fascinating. And we're working on trying to do some research on this. As you drive 395 south of Carson City, 395 comes down through here, and it makes a turn through the town of Walker, and then it comes down, and then ultimately ends up, Bridgeport is located here, and 395 going down, here's Mona Lake. These black blobs in here are part of the Eureka Valley tuff, and the term tuff is a volcanic ash, a welded volcanic ash. That was about 9 million years old. The little Walker caldera is the basin in which this tuff erupted in a gigantic eruption. It went up and flowed down, the tuff flowed down the Stanislaus River, and actually went all the way down as far as Sonora. When you take Highway 49 out of Chinese Camp and Moccasin, where the reservoir is down in there, and you start up just before you get to Sonora, you'll see this massive bluff, this volcanic flow, tableland flow in that area. It's about 180 feet thick. Underneath that is a tertiary gravel stream. They're right south of Sonora. They took $60 million worth of gold out of that stream. But that stream was buried by a volcanic flow that came from the east side of the Sierras. So next time you get out 395, you go through the little town of Walker, and the minute it closes down, the river's right next to you, and you're going down there before you get to the Bowie turnout, you'll see evidences of the vents from that eruption in that area. The source of that volcanic activity, the little Walker caldera, but the source of stuff that came through our area is around Virginia City. And the volcanic areas in Virginia City was the site of a super volcano in that particular area. Working with a fellow from Stanford, he has postulated and correlated and has some research going on. He indicates about 50 million years ago, there was a large molten mass of rock, a magma chamber, right on the Canadian, what is now our Canadian border, right up here in the northern part of the United States. In 50 million years, that large magma chamber has migrated in kind of a southeasterly direction down to here, the crosshatched area, and then it migrated and moved down in here to its present position today in central Nevada. So this is like a heat engine source for a hot air balloon. And as this big hot molten mass of rock flowed underneath the crust in this area, it heated it up and caused it to elevate and rise in these bigger areas. And then this thing heated up, and then you had massive explosions, and you had these super volcanoes and calderas, collapsed calderas, like Crater Lake on the area. But we're now discovering there are major super volcanoes located throughout Nevada. Yellowstone is a precursor to the same kind of thing happening here. So if you take a look at Chris Henry at the University of Nevada in Reno, and I work with Chris, their students are mapping these central Nevada supervolcano calderas, testing the volcanic rocks from those, and then going down through, and these black lines here are the ancestral tertiary gravel streams that the streams ran down through. And they're going down through and they're sampling the volcanic tuffs and volcanic flows on top of these old streams. And tracing where that stuff come from. What was the source of the volcanic activity? And these are the central Nevada caldera belt where the supervolcanoes came from. And from this is the distance from the Great Central Valley or Pacific Ocean, 250 miles. Go back into here, they show the present day profile is a blue line to go through here. And when these things were elevated, this is a pre-extension before the caldera collapsed. And they figured that the central area of Nevada was as high as 17,000 feet elevation. Central Nevada now is maybe average of 6 as you go across the state in those big areas. So the volcanic flows came down these streams and it's hot incandescent gases flowing down these streams. And this is then map of the northern Sierra, so on the Feather River and the Butte River, these yellow areas are the remnants of these volcanic flows on the ridge tops, and these black dots in here are sample locations where the graduate students are doing research